Okay, so this is the last presentation for quadrilaterals, construction of quadrilaterals, I should say. It's not the last presentation for the study of the quadrilateral, but for construction it is. So it's on page 207. And then I'm going to take this away, give ourselves a little bit more room here. All right, so I would ask the children, maybe I would review the terminology, but immediately they're going to point out something different, right? What's different? Of course, that's what's different. I added a stick. I joined two opposite vertices, two opposite corners with a stick. And why do you think I did that? Well, if you remember before, these quadrilaterals were very floppy, right? I could easily turn the rhombus into the square. I could turn the parallelogram into the rectangle. They were very floppy. By adding a diagonal, we call this a diagonal, by adding a diagonal, I have made these very sturdy. They don't change shapes. They hold their shape. Okay? So triangles are very stable shapes. If we can make triangles, then we have made a very stable shape. I don't know if you've ever noticed when you cross a bridge, if you look at the construction of the bridge, you're always going to find triangles. Okay? You're always going to find triangles because the triangle is the strongest shape. And yes, you're right. Every quadrilateral has been broken into two triangles. Okay, very good. All right. So at this point is when you would put out the nomenclature cards along with the definitions, do your 3-period lesson, and have the children maybe trace these into their notebooks and label everything, and definitely copy all the definitions into their geometry notebook. And I think that is all for the construction of the quadrilaterals.